Hello everybody, this is Mr. Rhodes. I know I'm not here today, forgive me for not being here, but this video should help you complete the notes and get some understanding on what the word converse is. So today we're going to talk about the Pythagorean theorem converse. Okay, and that's one of the vocabulary words for this particular unit. Now the converse of the statement switches the order of if and then. I want to box the word switches. So when we're talking about the converse, we're talking about how the orders of an if and then statement switch. So for instance, if a triangle has three sides, then it is equilateral. So let's write the converse. So I have if and then. So we're going to switch what it says. So I'm going to place if there and switch it with then. So if a triangle is equilateral, then it has three equal sides. Alright. So we have to make sure that statement is true before we go forward. And I do believe it's true. If a triangle is equilateral, then it's got to have three equal sides. So let's do the second one. If a number is even, then it's divisible by 2. So that I can write if a number is divisible by 2, then it's even. Excuse me. So, let's talk about the converse for the Pythagorean theorem. Right? We know so far that if a triangle is a right triangle, then a squared plus b squared equals c squared. So all that means is that if a triangle is a right triangle, then the Pythagorean theorem, our formula, will work for what we're looking for. Using the reasoning from above, write the converse. So I'm going to give you a couple seconds to try to think about what the converse might be. Okay, so you should have tried to change it around. If a squared plus b squared equals c squared, then we know we have a right triangle. Okay. The converse can help us to prove whether triangles are right triangles. Please pause it here. Excuse the noise, guys. There's people working while I'm trying to do this. So, right now, just like I told you the first couple days we've been learning this, the Pythagorean theorem, a squared plus b squared equals c squared, is primarily for proving that these triangles that we have here are right triangles. So we try to see if they fake or not, see if they fake in being right triangles. So this is how we do it. We're going to use the Pythagorean theorem converse to prove whether or not the following triangles are right. So first step we got to do is find our right angle. And it looks like to be right here. That one's pretty easy. It's pointing to our C. So let's go ahead and label it C, equal to 85. And remember, A and B are interchangeable, so it doesn't matter where I put them. Let's put this one as B, and let's put this one as A. Alright? So, if the converse is true, then A squared plus B squared should equal C squared. Okay? Let's see if that's going to be true. Let's plug in all of our values. A is 13, so I write 13 squared, plus B is 84, so 84 squared should equal 85 squared. Okay. Now all I have to do is put this part in the calculator and then see if I get this part. Alright? So we're taking the two sides of our equal sign and just making sure it works. Okay? Now 13 squared is 169. And I went to my calculator and I did 84 squared, and I got plus 7,056. Okay. And that should give me whatever 85 squared is. When I put that in my calculator, I get 7,225. And all you need to do is see if those two add together to give you what you're looking for. Alright? So let's see. I'm going to use my calculator here, my trusty dusty calculator. And I'm going to put those numbers in. 169 plus 7,056. It works! So, this one is true. This is true. That one works. Congratulations. You just used the Pythagorean theorem converse to prove that a triangle is indeed a right triangle. Pause it here, please. Now let's try to do the second one here. Let's make sure we have our right angle drawn first. And then we're going to point to our C, so we know that 21 is going to be C. 15, let's make that one B this time. And let's make 12 A. Okay? So all we're going to do is put our stuff in the formula. And again, our formula is A squared plus B squared equals C squared. And we want to make sure that this is true. A is 12, so I'm going to have 12 squared. Okay. B is 15, so I'm going to add 15 squared, which should give me 21 squared. Okay. So again, I can go into my trusty dusty calculator and clear everything out right quick, and I'm going to use it to verify whether this converse is true. So I can just put it in right here. 12 squared plus 15 squared equals 369. Okay? And all I have to do is do 21 squared. They do not equal each other, so this is not true. This is not true. Remember, these numbers, the 369 and the 441, they would have to have equaled each other for the converse to be true. Please pause it here. Okay, we're going to go to number 3 real quick. Now, the strategy that I taught y'all to make sure that the triangle, we can find the right angle, is to go ahead and turn your paper. Turn it until you find the base being straight up and down. Let's see, is that the one? Is that the one? Is that the one? Well, we really can't see if that's a right angle. Matter of fact, even if I draw it, it doesn't really look like a right angle. But again, remember, we're just trying to see if it's true or not. Okay? So this side here should be our C because it's opposite of the right angle. And then let's make this one A and this one B. Okay. So now I have A squared plus B squared equals C squared. And remember, I do it over and over again. I do the same thing over and over again so I can learn the process. Okay? I'm going to change the color right quick. Please excuse the noise. I'm going to change the color right quick and place everything in. So A is 30, so I'm at 30 squared, plus B is 15 plus 15 squared should give me 45 squared. Now what I notice is it's trying to tell me right now that 30 plus 15 equals 45. Okay? But we have to check the theorem. We got to make sure that it works. Okay? So again, I'm bringing up the calculator. I'm going to put my numbers in. Okay? So I have 30 squared plus 15 squared. And that gives me 1125. Let's see if it works. 45 squared. 2025. That one is not true. So this one is not a true converse. It's not. It doesn't make it true. Okay? Please pause. Okay, now we're going to do this last one here. Okay, and I'm going to move through it very quickly because, I mean, we practiced it 3 times, so you all should be able to keep up. Right angle. Right here. That makes that C. So we call this C, A, and B. A squared plus B squared equals C squared. A is 18, that's 18 squared. Plus B is 24. 24 squared should give me 30 squared. Let's use the calculator. Double check our work. Move it down here so we can see it a little bit better. In fact, move this over and move that here. So 18 squared plus 24 squared. And that should give me 900. And it looks like 30 squared is going to be 900. So yes, this one is a definite, it is a true converse. The converse is true. Go ahead and flip this over. If you need to pause right now so that everybody can copy that, please do. Okay. So the instructions here say, determine if the following side lengths would form right triangles. And use your proof. Show your work as proof. Okay? And we're going to show our work just like we did on the front page. Okay? So proof first. You're going to do the proof first and then the right triangle. Okay? I'm going to do the first 2. Okay? And you're going to do this one and this one by yourself. Please excuse the noise. Okay? So, I'm going to do the first 2, you're going to do the second 2 by yourself, and then I'm going to do number 6, and you're going to do 7 and 8 by yourselves. Okay? Let's do the first one, number 5. 12, 24, and 36. So, let's do A squared plus B squared equals C squared. Now remember, the longest side is the one that goes into C. Okay? Even if the numbers are jumbled up, you have to make sure that the biggest number goes where the C goes. Okay? So I'm going to write my proof. I'm going to fill the numbers in. Okay? So 12 squared plus 24 squared should give us 36 squared. Now I'm going to venture to say that this is not true. I'm going to say that this is not true. 36 squared, I'm sorry. But this won't be true. So I'm going to take my calculator out and try to figure some stuff out. See what it gives me. 12 squared plus 24 squared. It's 720. Okay. When I do 36 squared, it gives me 1296. That is not true. So, is that a right triangle? I'm going to write no. I'm going to write no. No, it's not a right triangle. It is not a right triangle. Let's do the second one. Okay, a squared plus b squared equals c squared. And remember, I told you c is the longest side. Let's go ahead and do the longest side. Is it 16, 9, or 11? Well, it looks to me 16 is the biggest, so I'm going to put 16 squared on this side. Okay, and the rest is going to be 9 squared plus 11 squared. Remember, the hypotenuse, or the c, has to be the longest side. If you put it here or here, you will not be doing the math correctly, therefore you won't get the right answer, and therefore you won't be able to prove correctly or prove adequately whether the converse is true or not. Okay, so let's go ahead and use our calculator. Let's put these numbers in where they go. So 9 squared plus 11 squared is 202. 16 squared, I have that memorized. 16 squared is definitely 196. Oh, 256, I'm sorry. 256. Yeah, no. Those don't match. So, is that a right triangle? No. It may very well be a triangle, but it's not necessarily a right triangle. Okay. So you're going to go ahead and do number 20. I'm sorry. Let's call these C and D. You're going to do C and D by yourself. Okay. If you need to, you can pause it and attempt them by yourself and then compare answers with a partner. Okay. Let's look at number 6. Jimmy thinks a window frame in his house looks slanted because the corner doesn't appear to be a 90-degree angle. His wife thinks it looks just fine. They measured the window to check and found the width to be 25 inches, the height to be 36 inches, and the diagonal distance to be 45 inches. Who is correct? Well, just like we did yesterday, if you need to, you can draw a picture. However, it gives you the information that we need. So we have 25 inches as a number, 36 inches as a number, and 45 inches as a number. Okay? And we want to know if Jimmy is correct or if his wife is correct. So I want to box some important information, and I think the most important information here is diagonal distance. Diagonal distance is really, really, really important. Okay? So we know the diagonal distance is 45, so that means 45 has to be C. Okay? So I'm going to write it like this. A equals, B equals, and C equals. So we can make sure to figure out what they each equal. Okay? So let's make A 25. A is 25. B is 36. And we already determined that C is 45. Okay? So, let's go ahead and write our theorem to make sure it is what it is. So, it should be A squared plus B squared equals C squared. Okay? Switch colors right quick. Okay, A is 25, so I write 25 squared plus 36 squared should be 45 squared. Here comes the calculator so we can help ourselves out. 25 squared plus 36 squared gives me 1921. 1921. Let's see if 45 squared is going to equal 1921. 2025. Is Jimmy is it correct? Jimmy's right. And he knew because the corner doesn't appear to be 90 degrees. But we still have to test it to make sure it is what it is. Okay. If you need to pause here so that people can get that written down, please do. Okay. And now I want to kind of move to number 8. It says the perimeters of 3 squares are shown below. Could the 3 squares be positioned so that they meet to form a right triangle? Why or why not? Now, this is a lot like the problem yesterday, and I'm going to draw pictures to help you understand where they had the triangle here, this square here, this square here, and then this square here. Excuse my drawing. Okay? They want to know if you can position these 3 like that. Okay? Now, it says the perimeters box that the perimeters of the 3 squares are shown below. So in order to find the perimeters, if they're squares, we always know that squares have the same side. So because they're perimeter, we can divide those numbers by 4 and catch what one side is equaling. 48 divided by 4 is 12, so this should be 12. Okay? 140, let me move that up a little bit. 140 divided by 4 gives us 35. So 35. So that side is 35. And 148 divided by 4 is 37. 37. Okay? So we have our A, we have our B, and we have our C. Okay? It's up to you to decide. Okay? So you're going to finish C and D and 7 and 8. And I've done half, almost all the work for 8. Okay? After you all finish this, you can start on your homework that you should have picked up on the way in the classroom. If you have any questions, refer to the notes, refer to the video, and this should help you out. Thanks, and I hope y'all had a wonderful day learning this way.